This is Lonnie Kringle, my name is Randy Sullivan, and we have the best job in the world because we get to do this for people like me. It is wonderful. We do chemistry demonstrations in our general chemistry courses at the University of Oregon. Chemistry is the science of stuff, and so you can only talk about stuff for so long without messing with the stuff. And that's our job. Of course, in your laboratory courses, you get to mess with the stuff yourself. But some of the stuff they don't particularly want you doing in your laboratory course, so we do it for you in the lecture courses. And that's what we do. We do lecture demonstrations. But what we've done for you today is we compiled the greatest hits of all the lecture demonstrations we do. The things we enjoy doing the most, have some fun with chemistry, and hopefully maybe learn a little bit while we're doing it. So, chemistry is science of stuff. We look at the properties of stuff. We call them substances. We look at how stuff changes into other stuff. The stuff you start, stuff. It's the stuff things are made out of, right? You start with, so a lot of what we look at is reactions. You start with some stuff and they change into other stuff. They're called chemical reactions. Do you think that was a chemical reaction?
Yeah.
Okay, you think that was a chemical reaction. Okay. Let's talk about this. The stuff you start with is called the reactants. The stuff you end up with is called the products. What do you think might be in the reactants in that reaction? What did we start with? Fire is kind of the source of energy. What substances?
Gas.
What stuff do we? Yeah, gas. Good. There was gas inside that balloon. Anybody want to take a guess? What gas?
Helium.
Helium. Do you think your mom would have lit that balloon near your little sister's birthday candles? Yeah. Right. Helium, good, because you observed one of the properties of that substance. It's less dense than air, right? You saw it trying to go up, and you know helium is less dense than air. But helium is not flammable. What? Wait, somebody said it? What? Oxygen was one of the reactants. It was outside in the air. Air is 20% oxygen. It's very reactive. Hydrogen, somebody said. Hydrogen inside the balloon combined with oxygen outside the balloon to make water. Now, at that temperature, water is a gas, steam. You may have seen some of it condense on the blast shield. Maybe not. And then evaporated again. So in this case, usually you can tell a reaction is taking place because the product looks different than the reactants. In this case, we had clear colorless gases reacting to make another clear colorless gas, steam. How did you know a reaction took place if they looked the same? Something blew up, right? Yeah. A lot of reactions are accompanied by large changes in energy, or large or small or whatever, changes in energy. We can kind of track what's happening with the reaction by looking at that. So, being a science, chemists try to apprehend nature, try to get a handle on what's going on by using two main tools. There's numbers, we do measurements, we perform calculations, and we use words. We classify things, we name things. And so reactions is what we do. So we have different ways of classifying them. We call that a formation reaction because I formed a compound, water, out of its elements, hydrogen and oxygen. We could call that an exothermic reaction because it blew up. It's exothermic releases energy. We talked about energy. We could also call that a I talked about formation reaction. A redox reaction because our model for describing what happens on the atomic scale is that electrons are transferred from one type of atom to another. That's redox. A very special type of redox reaction called a combustion reaction. And Lonnie, do we like combustion reactions?
I love combustion reactions.
Why do you like combustion reactions?
They burn.
This burns. That's what a combustion reaction does. Have you got another combustion reaction for us?
I do have another combustion reaction. So in that last reaction, we were looking at hydrogen as our fuel. In this case, we're going to use ethanol. That's what's in this squirt bottle. So I'm just going to squirt some in here. Here we go.
Okay, now ethanol is a liquid fuel. And we talked about, okay, hydrogen's the fuel, ethanol's the fuel. A fuel is one of the things you need for fire. What else do you need for a fire? Fire. Somebody said, what do you need for a fire? Fire. Yeah, you need a source of combustion. And then oxygen. Oxygen's in the air. Actually, oxygen was in the air inside that bottle, I think. But the problem is, we say ethanol is a liquid fuel, but actually it doesn't burn in the liquid state. Things actually have problems reacting in the pure liquid state or in the solid state. Because in order to react, the reactant molecules and the atoms need to be able to combine. They need to actually collide with each other. Now with a liquid, only the molecules of ethanol that are on the surface there can collide with the oxygen molecules. So most liquid fuels, like gasoline or ethanol, actually react in the vapor phase. They evaporate. And that's what Lonnie's been doing, rolling this bottle around, is trying to get some surface area so that ethanol evaporates. You know it does when the doctor puts alcohol in your arm. It evaporates and makes it cold. So we've got our fuel. We've got our oxygen. We need a source of ignition. You gotta just put a torch up to it.
Just light it?
I don't think that's a good idea.
Really?
No.
Okay, well I guess, yeah, I would have to burn through all the plastic and that would get messy.
It would be nasty.
So what if we use electricity this time?
Electricity.
So Nikola Tesla, great scientist, invented the Tesla Coil. And so he found that high frequencies and currents leak out. And so we can see this. We can go zappy zap. And so this is really fun. We get to be mad scientists at this point.
Wow. Now, I have a feeling that this is going to be our next loud demonstration.
I have a feeling too, so we should maybe cover our ears at this point.
Okay, so we learned something very interesting. Ethanol burns, and ethanol burns really well. Fuel-air mixture explodes. That's good. So one thing chemists or any scientist does is once we make a discovery like ethanol burns, we can turn around and do more chemistry with it. There's lots of different types of chemists. There's chemists who make things, synthetic chemists. There's biochemists who try to figure out the chemistry that goes on in life processes. There's a type of chemist called analytical chemist. Now, chemistry is science stuff. An analytical chemist's job is somebody comes up to them and goes, hey, what is this stuff? And they take it back to their lab, and she runs a bunch of tests on it and sticks it in some machines, does some chemistry with it, comes back and says, well, this is 33% blah, 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 and 12% blah, 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 5% blah, blah, blah. That'll be $10,000, please. Yeah, nice work for you, right? So, analytical chemists. Well, analytical chemists, one of their jobs is to figure out what's in stuff. And one of the things that's tough to figure out what's in stuff a lot of times is the metals. Now, you know periodic table, most of the elements are metals. They've got a few non-metals up here in the corner up here, but most of them are metals. And when they're actually just in their elemental form, they're easy enough to recognize. You know, you hand me a lump of copper, I can recognize it's copper. But once it reacts, it loses its electrons, and it could change into a compound that's like a white crystalline solid. Geez, there's zillions of white crystalline solids that dissolve in water, right? And once it's in there, that metal ion will just sit there like a chemical bump on the log. There's hardly any chemistry test, not a lot you can do to figure out what's in there. There's tough. But there's a real cheap and easy way. You heat it up, and the electrons that remain get bumped up to a higher level and fall back down. When they do, they give off a characteristic color that you can attribute to a particular metal. So this is called the flame test. Now, I was actually doing it in the lab. I do it a tiny bit at a time. But, oh yeah, I forgot to switch up there. I do it a tiny bit at a time, like maybe dip a little Q-tip in it, put it in my Bunsen burner, and go poof, the color. But we do demos in Columbia 150. Did you guys go through Columbia 150? Is that huge classroom over there? If I can't do something that small. I'd have the people on the back row and on Facebook in no time flat because they'd be bored. So I had to make it big, and I had to make it exciting. So I found around me, calling across the floor. No, I found these spray bottles. They're really cool. You put whatever you want in them. So I started thinking of the things my mom told me not to do. So I said, let's put some ethanol in them, and then let's put some metal salts in there so we can identify who the flame test supersize. So let's see what this looks like. Wow! What color is that? What color is that? Green. If it's green, I think that's a copper salt, isn't it?
That is a copper salt, yes. So it doesn't look like the copper we're used to.
Okay, so you see, I can tell by the color which one should do it. I swear we didn't work this out for you.
Red.
Okay, that's either lithium or strontium. I'm going for strontium.
Lithium.
Oh! Well, being colorblind.
Yeah. This is a fun game to play with Randy because he's colorblind, so I kind of make him guess what color it is.
You did them out of order. No, just kidding.
No.
That's a strong game. No, that's sodium.
That is sodium. Our spray bottle's having problems.
I know, we need to clean them.
Okay.
That really bright yellow sodium, it's everywhere.
Can try one more.
Okay.
It's my favorite one.
Ooh, that's pretty. It kind of sputters a little bit. That's potassium. So a potassium salt dissolved in ethanol. And potassium also has a flame retardant property, so you saw it kind of sputter. But it is a really pretty color of blue, blah, blah, blah. Okay.